Okay, let's recall. As I just mentioned, we're going to dive back into circles today. We're going to look at arc length, or we're going to look at distances traveling around the edge of a circle. The basis of this is going to be the circumference formula for a circle. So, do we remember the formula for the circumference, or the distance around the circle? Going once.
Oh wait, it's diameter.
That's the
Pi r squared is area.
2 pi r is
2 pi r is exactly the circumference. Is equal to twice the product of pi and the radius. And the alternate formula, by combining 2 and r, what's twice the radius, also known as the diameter. This is the same as pi times the diameter. Keep in mind, pi is the mathematical constant that you get. Specifically, if you're taking a circle and dividing its circumference by its diameter, and you get this lovely constant of nature, pi. Pi is approximately 3.14. It is not equal to 3.14, but it's close to. For the purposes of this, for our work, whenever we use pi, I'd like you to use the pi approximation in your calculator. So I don't want to just see like 3.14, just it's called truncated. I don't want you to stop there. I'd like you to actually do 2 times your radius times the pi function in your calculator and give me an answer. And we'll round the final thing, not just have this piece in here. Neither here nor there. So anyways, just recall a little picture here. Here's your radius. The circumference, therefore, is this length. It's just the length around the edge of a circle. So all we need to know is either the radius or the diameter, if you so chose. And you can find the circumference of the circle. So I got a couple example problems down here. Just chugging along with this, with our formula from years past. So in exact terms, the circumference of these circles would be, well, let's see, if this is the radius, then the circumference is equal to twice of pi times the radius. An exact answer for this, kind of like when we had exact answers for radicals, we did not use decimal approximations. We left them as like a square root. In this case, pi is a constant. It's actually called an irrational number. It's also even more broadly called a transcendental number, but that's not a huge deal. The exact answer for the circumference of this circle is 14 pi centimeters.
Oh, no,
This would be the exact answer. Now, sometimes the exact answers aren't really the most convenient answers. Like, when would you really want an approximate answer? Like, when would an approximate answer, or the decimal representation of that, make more sense? Like, when would it be more useful? Yeah, like if you're comparing it to something, like, I want to know, like, I want you to give me, like, does anyone have a feel for how big 14 pi is? If I ask you to put 14 pi in a number line, would you know where to put it? Yeah, so it's a lot easier to get a feel for how big this number is if you found the decimal approximation. So if you take your calculator and do 14 times pi, we can get an approximate answer, which is approximately, did someone do this? 0.9 what? So an approximate answer for the circumference of this would be approximately 43.98 centimeters. Exactly, it's 14 pi. This is an exact answer because I don't have to round this decimal. I don't have to do any of that junk. By approximating, I'm inherently having to round this because pi never ends. So this decimal actually never ends. It just keeps going on irrationally forever. But this is a lot better. I actually have a feel for what 43.98 centimeters is. 44 centimeters is about half a meter. I can actually get a better approximation of that. Okay. For B, pretty similar. Now I tell you the diameter. So the circumference is equal to pi times the diameter. This one's even easier. Circumference is 20 pi feet. Or again, you may not have a good feel for what 20 pi feet looks like. An approximate answer for 20 pi feet is, what do we got here? 20 times pi. It's about 63, you said? 62.83 according to this calculator. Again, I'm vague. I was vague with how I'd want your answer left, so either one of these would work. 20 pi or 62.83 feet.
Why didn't you say exact? Oh.
Again, the directions were vague, so I didn't. For the next one, I say the exact diameter.
Yeah, no, I thought that was.
Yes. So the next one, I say the exact diameter of a circle with circumference of 39 centimeters. So I know the circumference is equal to pi times the diameter, or 39 centimeters is equal to pi times the diameter. So the exact diameter in this case, divided by our favorite constant of nature, some of your favorite Greek letters, and we end up with diameter is exactly 39 over pi centimeters. Again, this is an exact answer because it's not rounded. There's no decimal rounding going on here. It's 39 divided by pi. Exactly. You could get an approximate by type this in your calculator, hit enter, and get the decimal representation, but I asked for the exact diameter and want an exact answer. We're going to kick it up a notch, and we're actually going to be able to describe what the arc length of any arc is within a circle, based off of that previous theorem. And the idea is that an arc length, the measure in degrees of an arc length is proportional to the measure to the length of the actual arc. The arc length theorem says that the ratio of the arc length to the circumference is equal to the ratio of the arc measure in degrees to 360. Or maybe a picture of this might be I call this, say, arc 1. What I'm saying is that if I find the ratio of the length of this arc and compare that to the entire circumference. So if I say arc length to circumference, arc length to circumference, or if I measure around this little piece as compared to the going around the entire circle once, that ratio is the same as the degree measure of this arc to 360, or going entirely around a circle once. Okay? This ratio in degrees is the same as for this arc to the entire circle, or 360, is the same as the ratio of this chunk walking around the outside as to walking around the whole circle once, is what this proportion is saying. So if we can find those things, then we're in business. Okay? If we know something about those, then about, say, these two, then we can find the third. So for example, I want you to find the arc length of arc AB. Find this minor arc. from our theorem, we know that the proportion of the arc length around AB, I'm sorry, not. The arc length of AB divided by the entire circumference of this circle. Well, the circumference of this circle is what? 2 times pi times 6. 16 radius. That's going to be equal to the degree measure of this arc, which is 120, over the degree measure of this entire circle, which is 360. Which means now you have a proportion, now you should be able to cross multiply and solve. Or you say 360 times the arc length of AB is equal to what, 120 times 12 is 1440 pi, divided by 360, and that's what, 9 pi? 9 pi, or what's 9 pi as a decimal? Is that? Nine pi is not 12.96, so maybe I. Yeah, it's got to be in that area, Alyssa. Like 20, yeah, about 28.27, I believe. Did I?
No, it should be 4 pi.
36.
No.
Yeah, you're right. Yeah, 4 pi. Yep, you're right, 4 pi.
Yeah.
Yeah, I divided 440 divided by 360 is not 9, it's 4. That makes more sense.
Yeah.